Hi, this is David Syme. I'm the Vice President of Engineering and Delivery at Contava, and I sit as the Chairman of the PSA Technical Committee. My technical tip for everyone today is the security network health monitoring and how we implemented it at Contava. So why security network health monitoring? In the end, we just want to better understand the health of the network. That's done through a few different means. It's knowing when there is a fault on the network, so we have a failure, and we don't need the end user to notify us of that. If there's a camera failure, it's not when we review the video that we find out that there's a problem. So it's just gathering all of the faults on the network and being able to react to those. There's a proactive component, which is the performance management. So understanding the capacity of the network and the various subcomponents on amongst the network, and knowing how utilized those are, and better understanding of how the system is performing, underlying the necessarily how the end user experiences the platform. And then lastly, there's a predictive element of this. So this is being able to look into the future and say that we will experience problems in the future, and being able to do that trending activity based on the data that we're collecting. We do improve system performance. I'll talk a bit about how that's achieved. We improve our customer relationship. We're calling them as opposed to them having to call us about something being broken. We increase the return on investment that those customers made in their security network. It's going to be more available and perform better for them, and therefore we're going to have a return on investment, or increase our return on investment. And lastly, for the integrator, we do have an increase in margin and RMR, which I'll talk a bit about as well. And just a comment, my background is the wireless industry, wireless telecommunications. So we spend a lot of our time, or most of our time, just trying to find out how to take data from all these disparate components of the wireless network and understand when we had a problem. And so, as you know, as a mobile user, you start having drop calls in a certain area, or your data speeds drop off. It's frustrating, and you don't want to have to call the carrier. Well, we did what we could to understand where we either had a performance issue, so a capacity issue on the network, by pulling all this data from these different systems, or different components of the system, and as well as seeing when we had a fault, and that fault we could react to. And much like a security system, the mobility networks are built with numerous different manufacturers, or built from numerous different manufacturers. We did that with millions of dollars of investment in the head end, and a significant investment year over year to maintain the system and upgrade it. With security and where the technology is gone, the cost to get into this is a very small fraction of that, and to maintain is a very small fraction of it. So the return on investment is definitely there. So generally, this is how the architecture looks for network health monitoring. There's a head end. Now, that head end could be a dedicated health monitoring system, or it could be the VMS. Video management system. Some have health monitoring, or you'll have an access control system with a manager in there. But anyway, this is the software the end user will connect to. It can exist inside or outside the network. In our case, we implemented that head end in a hosted environment, so it's outside of the customer's network. For this architecture to work, especially having it outside of the customer network, we have to install these probes inside of the security network, so close to the equipment. Now these probes are just little pieces of software that run on a server, your VMS, or an access control server, or some server that is going to be available to run the software. The communication between the probe and the head end is a secure link. It's an SSL link, and therefore you can have that traverse the internet with no worries. Now we're going to connect all of the cameras inside of the security network. We can connect all the network connected cameras and encoders, servers, switches, UPS, access control intrusion panels, and any other I/O device that happens to be network connected. We can monitor that in some form or fashion. And we're going to monitor that with a few standard protocols. SNMP is one of them. That's most network hardware manufacturers support SNMP. there's WMI, which is the Windows Management Interface. Let's just talk with the Windows servers, and then the switches and the various manufacturers have their standardized protocols. With Cisco, it's NetFlow. So all of that data is rolled up. Those probes are touching those devices. The data is rolled up and aggregated inside of the probe and then sent to the head end so that you can view the data. And that's where the database sits as well, so you can see historical data and see the trending. So what we did was we bought the licensing for a network health monitoring tool for our geographical area. We rented some colo space, or leased some colo space. So colo space is just a rack space in a data center. We give your data connection, your heat, your cooling, your power is all included in there at a pretty low cost because you're using shared infrastructure. Put in a firewall so we could have those secure connections to the customer site. Then there's we built out the servers and we use VMware so that we could do the failover and be able to go to a standby site and fail the system over as required. So that was the extent of implementing our cloud service, which is actually relatively low amount of effort when you look at it. However, the whole planning that went into it was probably a much higher level of effort. So now let's look at the tool.
This is the user interface. Up at the top here we have an alarm banner with alerts, as well as showing the devices that are healthy. There's a lot of devices being monitored on this system, so we're bound to have a few outages here. Each of the devices can be grouped together, so we've grouped them logically here. A camera looks like this in the tool. We see right now it's effectively 0 milliseconds to ping that camera, so the latency is low. The control interface is responding in 32 milliseconds, so that is healthy over time. There's also a bit rate being produced here right off the camera, so we don't have to look at the network to see how much bandwidth it's using. And as well, we have an uptime calculation, so we can see over time that the uptime slowly increases, and we'll see if when that drops off. This is what an archiver looks like, or it's a Genetec archiver. It's an NVR. So on the server, we get to see the if it's alive, the CPU load, the memory utilization, uptime as well, and any of these sensors, I can go and drill down and see more about it over time. And this one has U against it, so it's unusual activity. Usually it sees this bit rate while it's seeing some other bit rate there. So it's got some predictive elements to it there. Here's a directory server, a Genetec directory server. Ping, CPU load, memory available, and a key one here is we can actually watch the various processes that are important to the system. So you have the server's alive, the operating system is healthy, but are the services underlying the making up the overall solution, is it healthy? So for example, we have a customized SCADA interface to SCADA that we wrote here, and we just want to make sure that it's available, so we can do some monitoring of that and alert off of it. We have a NVR here. If you click on it, we can quickly see a view of the health of that recorder over time, all of the disks. This is a bandwidth sensor on a given workstation, or a server, and we can see over time how much data is going in and out of that server. And it's important that we know the maximum capacity of that server is 150 megabits per second up. So here we can quickly monitor to see if we're getting close to that threshold. And as you can see during the day, there's a definite variation. So we can see if possibly there's some symptoms related to symptoms that are related to certain periods of the day, and we can identify when that's happening and hopefully why. This is a core switch, so we're watching all the bandwidth on numerous interfaces here. Now here's a very interesting view of the video management system, which gives us a lot of insight to the overall behavior of the system, the performance of the system. We're viewing right here one interconnect between two core switches with 1,000 high-definition cameras flowing through that link. And so that aggregate bit rate is significant, and it changes over time because as the cameras have more motion in the field of view, we will get a higher bit rate. The environment is a transit environment, so you have commuters entering and exiting platforms, and as you can see during the day, or you start at 4 a.m. in the morning at the low point, you slowly reach a peak at about 8 a.m. during the morning rush hour. And as that commute kind of ramps down for the morning, it plateaus and then increases again during the end of the day. As we reach 4 or 5 o'clock, we see another peak, and then it ramps off. Then we see one last bump here, which seems to correlate when the bars and restaurants close, and we see that ramp down again till the wee hours of the morning before the pattern continues. And if I look at the 30-day view here, it's entirely cyclical. At these 5-day periods, we get the same signature over and over again, followed by these weekend Saturday, Sunday humps, and repeat five days over and over again. So I find it so fascinating that we're seeing the behaviors and the patterns of the people of the city showing up in our monitoring of the health of the system. And not only is that just interesting, but we get to start diagnosing why, for example, on the 26th, we started to see some symptoms for the end users, the guys viewing video, because maybe that's where we're starting to reach a threshold in the capacity of the system. So lastly, I'm going to show you a UPS runtime report. So here, click on it, we run it, and we can sort on the last value, or the actual average values of the runtime. So the health monitoring tool is measuring the UPS. It gets a runtime back from it and tracks it over time. So we're going to see a decrease in the capacity of the UPS as we add equipment, for example, so we can monitor that. And maybe there's a threshold where after we need to meet a 60-minute requirement for our UPS in case of a power failure. So we'll quickly be able to see that and be able to identify when we add any more. If we're going to add more equipment, we're also going to have to upgrade that UPS. In addition, the performance of the UPS is going to degrade over time as the batteries age, and so you're going to see that as well. So you'll be able to see a graph over time and trend off of that graph to see when the runtime values are going to cross a threshold that's important to you. So if it's 60 minutes, and that looks like it's going to happen in about a year's time, now you can start having that conversation with the customer about budgeting to do the maintenance on those UPS. Okay, finally, I'm going to go through a couple of case studies just to show you how we utilize the network health monitoring and some of the return on investments that we saw. So the first case study here is a small health facility, which was a decent distance away, so it was costly to go visit, but there were issues following the installation. And it was possibly related to the IP layer, the network layer, but in the end we had some conversations and it was unclear whether there was actually still an issue with the network layer that was supposed to be resolved, and so we're left with a pretty muddy situation, and we needed to find an exit to that and just get the symptom solved. And so instead of sending out the troops right away, we took 20 minutes to remote into that system. We installed the software package, that probe, and started collecting data. We left it run for 3 days. So a 20-minute investment initially, and then we let it run for 3 days, and we were able to come up with a report on the behavior of the network. And that was like no tuning of the system whatsoever. We just said, okay, how is the health of the network layer? Are we seeing drop packets? And in the end, it was very clear that our symptom was not related to the network, and that we had to go out there and replace the hardware. And it ended up being a hardware issue, so we ended up sending the right guy to go do that work. It was not a network issue. At the same time, we diagnosed some other issues on the network. There were some pieces of the network that were not staying up and were related to other symptoms, so we got some insight there. Next case study, this is a larger one. So the city of Calgary experienced a 150-year flood and $6 billion in damage, a lot of that to the downtown core where a lot of the infrastructure that we were responsible for was. Now, as you can see in these pictures, over time, the water crept up this transit platform, and as it crept up the transit platform, we started seeing failures. So that status board that we were watching started going from green to red, and there we could see that the network elements, the peripherals, were starting to fail. And then finally, all the cameras went down, and well, these, you can see in this picture, the UPS and the switches had definitely failed. And the network health monitoring wasn't going to improve or stop any of those failures. However, it was able to give us some insight. When we watched the failures, we could see what was failing and when. As we saw the news feeds coming in of the flooding, and we're watching that board, the dashboard showing component failures, we could see which actual stations, each locations that were failing. So we started counting up the devices that were failing. We would see the peripheral devices were failing, and then the servers and switches. So we had insight into what was going on there, and we could immediately start planning on the recovery. Now, when we did get in there to recover, we had entire visibility in what had to be left to be done. So we tackled the network layer first, and we made sure that we changed all the red marks on the dashboard to green, and then we moved on to the application layer and the peripheral devices. And to go in there and recover all those devices, we could see over time what still had to be recovered, and what might be the components that needed to be replaced to recover it. And during that recovery, we could communicate with the customer and give them confidence that we knew what was required to complete that job, and giving them an idea of how long it was going to take. So we took reports, just snapshots directly from that dashboard, and we're able to share them with the customer to show our progress. We gave them entire confidence in our capability of resolving it, and it definitely shortcut that recovery effort. So now I'm just going to go back to the return on investment, which I feel there's a significant return on investment for both the customer investing in a network health monitoring as well as the integrator. So first off, the last mile cost, and I'm referring to that, we've got everything installed, all the components, the software components are there. However, we still have some sort of symptom, and we're still doing tuning on the network. It's not 100%. We haven't resolved all the deficiencies. We can significantly shorten that period of time because now we have the intel about the underlying network performance to see if we've got any work left, or if we've got some returns to process, some RMAs to process. We got some warranty issues with some of the subcomponents. So significant return on investment there. I'm calling it 10 to 1. We think we have reduced truck rolls because we don't have to go back and visit site multiple times. We're being able to bring the right part to site the first time. We have more insight into what's at the customer's network. We're sending the right resources. So, is it a security technician because there's a camera failure, or is it a switch failure? So we can do all that diagnosis remotely, or a large majority of the diagnosis remotely. Now, reduced risk. So this is from the customer's perspective. Now, our customers invest in their security platforms because they're trying to reduce some sort of risk and justify their investment in that security infrastructure by reducing some risk. Now, if the system or the components are not performing, you're not reducing that risk anymore. So when you have a possibility of a downtime, that is reducing the ability for the investment to reduce risk. And this system, network health monitoring, definitely increases the availability of the system because you're responding faster, you're identifying some possible future problems and being able to address them. You're seeing hard drives with predictive failures. You can go out there and resolve those issues, things like that. So I think it could be a massive return on investment for a customer with respect to reducing the risk and the initial reason for investing in the infrastructure. In addition, we see a 5 to 10% increase in our service contracts because, one, we're selling them the health monitoring service, but we're also selling them the service of responding to those to those events and that SLA. In addition to that, just the ongoing service business with that customer increases significantly, because now we know what's broken and we're out there going to fix it, and we're putting all that time into servicing and doing preventative maintenance of the overall network, as opposed to seeing small components underlying fail until we get into a major problem, or the platform gets to end of life because it wasn't maintained properly, and an RFQ goes out and we lose the business because we weren't the cheapest guys. So just being on top of that and getting the most out of that investment also increases the service business for us. All right, thank you very much for watching. If you have any questions or want to learn more, please contact the PSA Technical Committee by visiting buypsa.com.